What if every time your employees connected to the internet from home, from a coffee shop, or from an airport, their traffic was automatically protected by enterprise-grade security, using the same corporate identity they already have in Microsoft? No separate passwords, no local accounts on the firewall, no manual provisioning. If someone gets offboarded in Entra ID, they lose VPN access instantly, automatically. That's GlobalProtect with SAML authentication backed by Microsoft Entra ID. I'm going to show you how to build it from scratch on a real Palo Alto firewall. Every click, every field, every gotcha. Let's build it. Step 1, SAML integration with Microsoft Entra ID. The first thing we do before touching the firewall at all is configure the identity provider. Open the Azure portal and go to Microsoft Entra ID, then Enterprise Applications. Click New Application. In the search bar, type Palo Alto Networks GlobalProtect. Microsoft has a pre-built gallery template for this. Select it and click Create. Give it a meaningful name like GlobalProtect VPN so your team knows what this application does. Once the application is created, go to Single Sign-On and select SAML. You'll see the SAML configuration page with 4 sections. We'll fill in the URLs for Entity ID, the SSO URL, and the SLO URL with our portals. The format is https:// your firewall's public IP or FQDN /SAML20. Don't forget to fill the correct suffixes as described on the user interface, and also append port 443 on the URL as shown. Then let's grab what Entra gives us. Scroll down to section 3, SAML certificates. Download the Federation Metadata XML. This single file contains everything the firewall needs: the entity ID, the SSO URL, the SLO URL, and the signing certificate. Keep this file ready. Now, critically important, go to User and Groups inside the application. Click Add User/Group. Add a security group from your directory, for example, a group called VPN Users. Only members of this group will receive a valid SAML assertion for GlobalProtect. If someone isn't in this group, Microsoft will return an error before the firewall ever sees the request. This is your first enforcement layer at the identity provider level, before any firewall policy fires. Step 2, SAML Identity Provider Profile on the firewall. Switch to the firewall. Go to Device, Server Profiles, SAML Identity Provider. Click Import. Name this profile Entra ID SAML. Now, instead of filling in each field manually, click Import Metadata and select the Federation Metadata XML you downloaded from Azure. The firewall will parse it automatically and populate the Identity Provider Entity ID, the SSO Service URL, the SLO Service URL, and import the signing certificate. This saves you from manual errors. Review the imported values. The Entity ID should look like the Microsoft Entra domain URL. The SSO URL is where the firewall sends authentication requests. Make sure Validate Identity Provider Certificate is disabled. Here's why disabling certificate validation is safe. In SAML, each assertion is independently signed by the IDP's private key. The firewall validates that signature regardless of TLS certificate validation. The real security in SAML lies in assertion signing, not in the TLS layer. Set the maximum clock skew to 60 seconds. SAML assertions are time-sensitive. If your firewall clock drifts from Microsoft servers, authentication will fail. If you're seeing mysterious SAML failures in production, clock skew is always the first thing to check. Make sure your firewall syncs NTP. Click OK. Now go to Device Authentication Profile. Click Add. Name it GP SAML Auth. Set the type to SAML. In the IDP Server Profile field, select Entra ID SAML. For the username attribute, enter the claim name that Microsoft sends. By default, it's username or the name ID. If you've customized claim mappings in Azure, match this to whatever attribute contains the user's UPN. Click on the Advanced tab. Under Allow List, you can add all for now. This means any user who successfully authenticates through Entra is allowed. Click OK. Authentication is fully configured on the firewall side. Step 3, Certificates, and why you still need them with SAML. Here's a question I get every time I teach GlobalProtect with SAML. If Microsoft handles authentication, do we still need certificates on the firewall? Yes, absolutely, and here's why. SAML and TLS solve completely different problems. SAML is about identity. Who is this user? Are they allowed in? What groups do they belong to? TLS is about transport security, encrypting the HTTPS connection between the GlobalProtect client and the firewall portal and gateway. These are 2 independent layers. SAML runs on top of TLS. You need TLS working before SAML can even begin, So we still need a server certificate for the portal and gateway HTTPS endpoints. Let's create it. Go to Device, Certificate Management, Certificates. Click Generate. First, create the root certificate authority. Name it GPRootCA. Leave the common name as GPRootCA. Check the certificate authority box. This is critical. It marks this as a CA that can sign other certificates. Set the key size to 2048 or higher. Leave the digest as SHA 256. Click Generate. The firewall creates the root CA and stores it internally. Now create the portal server certificate. Click Generate again. Name it GP Portal Cert. In the common name field, enter the exact public IP address or FQDN that your users will type to connect, for example, vpn.contoso.com. This must match character for character. If there's a mismatch, the GlobalProtect client will show a certificate error and users won't be able to connect. In the Sign By field, select GPRootCA. This creates a chain of trust. The portal cert is signed by your internal CA. Click Generate. Now, important point. Because this certificate is signed by your own CA and not a public CA like DigiCert or Let's Encrypt, the GlobalProtect client won't automatically trust it. You have two options. Option 1. Export GPRootCA and push it to all client machines via group policy as a trusted root CA, proper enterprise approach. Option 2. Use a public CA certificate for the portal, users' devices, already trust public CAs out of the box. For this lab, we're using the internal CA and will deploy trust via the GlobalProtect agent configuration. We'll cover that in Step 5. Step 4, SSL/TLS Service Profile. Go to Device, Certificate Management, SSL/TLS Service Profile. Click Add. Name it GPSSL Profile. In the Certificate field, select GP Portal Cert, the server certificate we just created. This is the certificate the portal and gateway will present to connecting clients. Set the minimum TLS version to TLS 1.2. This is important. TLS 1.0 and 1.1 have known vulnerabilities and should never be enabled in a production environment. If your clients support it, setting the minimum to TLS 1.3 is even better. Click OK. This profile will be referenced by both the portal and the gateway configuration. Step 5, Portal Configuration. Go to Network, GlobalProtect Portals. Click Add. On the General tab, name it GP Portal. Select the external interface, the one facing the internet, and the IP address on that interface. This is the endpoint where users will connect. Click on the Authentication tab. Select GPSSL Profile in the SSL/TLS Service Profile field. Now click Add under Client Authentication. Give this entry a name. Set the OS to any so it applies to Windows, Mac OS, iOS, and Android clients. In the Authentication Profile field, select GP SAML Auth. This is the critical link. The portal now delegates authentication to Microsoft Entra ID via SAML. You can also layer device certificates on top of SAML for a true two-factor setup, something you have plus something you are. But that's a separate video. For today's lab, SAML alone is sufficient. Now click the Agent tab. This is where you configure what the GlobalProtect client does on the user's device after they authenticate. Click Add to create an agent configuration. Name it Standard Config. Under the Gateways tab inside the Agent Config, click Add and enter your gateway address. Since portal and gateway are on the same firewall, use the same external IP. Set the priority to highest. You can add multiple gateways with different priorities for failover. The client automatically connects to the highest priority reachable gateway. Under the App tab, you can configure the welcome page and the portal certificate. If you want to distribute the GPRootCA to clients automatically, so they trust your internal CA, you can add it here under the Trusted Root CA tab inside the Agent Config. The GlobalProtect client will install it on the device the first time it connects. Step 6, Tunnel Interface and VPN Zone. Before we configure the gateway, we need to create a tunnel interface. This is a virtual interface, no physical port, no cable. Its only purpose is to terminate VPN tunnels. Why does this matter architecturally? Because the tunnel interface sits in its own zone, a zone we'll call VPN Zone. This is how the firewall distinguishes VPN traffic from regular internet traffic. Without a dedicated zone, you couldn't write security policies that say VPN users can access these resources but not those. The zone is the boundary. The tunnel interface is the door. Go to Network, Interfaces, Tunnel, click Add. Name it Tunnel 100. There's almost nothing to fill in here. The only thing you need to configure is the zone. Click on the Config tab inside the tunnel interface. Under Security Zone, click New Zone. Name it VPN Zone. Click OK. The tunnel interface is now in VPN Zone. Click OK to save the interface. Now go to Network, Zones, and find VPN Zone. You can optionally enable User ID here. This tells the firewall to associate VPN traffic with the authenticated username from the SAML assertion. If you enable User ID on the VPN Zone, you can write security policies using usernames and group names directly, not just IP addresses. For example, group VPN admins can access servers in the trust zone. Group VPN staff can only access specific applications. That's a level of control a traditional VPN simply cannot match. Step 7, Gateway Configuration. Go to Network, GlobalProtect Gateways. Click Add. On the General tab, name it GP Gateway. Select the same external interface and IP as the portal. Click on the Authentication tab. Select GPSSL Profile. Click Add under Client Authentication, set OS to any, and select GP SAML Auth again. This is a step many people miss. The gateway authenticates the user independently from the portal. It issues its own SAML challenge. The portal connects you to the network. The gateway validates you again before allowing traffic through the tunnel. Both need the SAML profile. If you skip this, users will authenticate to the portal successfully but fail at the gateway with a cryptic error. Click the Agent tab. Check the Tunnel Mode box. This is what creates the actual VPN tunnel. Without this, GlobalProtect runs in clientless mode, which is limited to web applications only. In the Tunnel Interface field, select Tunnel.100, the interface we just created. This is where all VPN tunnels will terminate. Under IP pools, click Add and enter the IP range for VPN clients. For example, 10.200.0.0/24. Every user who connects will receive an IP from this pool. Make sure this range doesn't overlap with your internal subnets. Under the DNS settings, you can push DNS server addresses to VPN clients. Push your internal DNS server so users can resolve internal host names while connected. Under Split Tunnel, you make a fundamental architecture decision. Full Tunnel sends all traffic through the VPN, complete visibility, maximum control, higher bandwidth cost. Split Tunnel sends only internal subnet traffic through the VPN, lighter on bandwidth, but you lose visibility into what users do outside the tunnel. For financial services, healthcare, or government, Full Tunnel. For general corporate use, Split Tunnel is common. Step 8, Security Policies and Commit. Before committing, we need security policies. Without them, the firewall blocks everything. Go to Policies, Security. Click Add. Allow VPN users to reach internal resources. Name it Allow VPN to Internal. Source Zone, VPN Zone, the zone your tunnel interface is in. Source address 10.200.0.0/24, your VPN IP pool. Destination Zone Trust. Destination address any. Applications, any in production. Lock this down to the specific applications your users need. App ID give you granular control that generic ports never will. Action Allow, click Commit. Step 9, Testing and Verification. With the commit done, let's verify the full flow. First, test the SAML redirect. Open a browser on a client machine and navigate to your firewall's external IP, the portal address. You should be immediately redirected to Microsoft's login page. This redirect is the SAML authentication request. If you land on the Palo Alto portal login page with a username and password box instead, the portal is still using local authentication. Go back and verify the client authentication profile in the portal is set to GP SAML Auth. On the Microsoft login page, authenticate with a user who is a member of your VPN users group in Entra. Complete the MFA prompt. You'll be redirected back and the agent picks up automatically. Open the GlobalProtect agent and enter the portal address. The SAML flow happens inside the agent window. A browser pops up, you log in with Microsoft credentials, and when complete, the agent shows a connected state with a green icon. Now let's verify on the firewall. Go to Network, GlobalProtect Gateways, Current Users. You should see your test user listed with their UPN and a tunnel IP address from your 10.200.0.0/24 pool. Go to Monitor, Logs, System Filter for GlobalProtect. You'll see authentication events, tunnel establishment events, and any errors. If SAML is failing, look for authentication failed entries. The detail field will tell you whether the failure was at the IDP level or the firewall level. GlobalProtect with Enterprise SAML authentication is live. Every remote user now authenticates through Microsoft Entra ID. You've built a full GlobalProtect deployment. SAML with Entra ID, certificates, portal, gateway, tunnel interface, and security policy. Offboard a user in Entra and they lose VPN access in seconds. That's enterprise security done right. If this tutorial helped you, subscribe for weekly Palo Alto content. Drop any questions in the comments. I read everyone. See you in the next one.